In this video, I'm going to go through the Midterm Review 2 packet for congruence and proofs. So for number 1, two right triangles must be congruent if. So it's talking about two right triangles. So I'm going to just sketch two right triangles. If an acute angle in each triangle is congruent. So let's say if something like that's congruent to that. Well, the problem there is I don't know anything about the side lengths. And if I'm thinking about side, angle, side, for all of those proofs that we did, we're going to need at least one side congruent, so number 1's not going to help me. What about if the lengths of the hypotenuses are equal? Well, if I didn't have those angles there, let's consider these two triangles, and let's just assume their hypotenuses are equal. The problem is, even if I wanted to use hypotenuse leg, I would need one of the legs to be congruent as well. But then number 3 says that, well, what about if the two legs are congruent to one another? Well, the idea here is that this looks like a side angle side proof because all right angles are congruent. So if I had number 3 to be true, that would be enough to state that these two triangles are congruent by side angle side. For number 2, given this triangle right here and side AC extended, which value of x makes AB congruent to CB? Well, if this was an isosceles triangle, I know those two base angles would be congruent. So if I take 180 and subtract 62 from it, I get 118. And then if I divide that by 2 to find my two congruent base angles, I find that they're both 59 degrees. Now don't get too excited here even though you see it as an answer choice. We are looking for the supplement to that 59 degrees right there, right? Because that's a linear pair. Those are two angles that lie on a line. So if I take 180, subtract 59, I end up with 121 as that obtuse angle there. For number 3, line segment EA is the perpendicular, so it's a right angle, bisector, so it creates two congruent parts, of ZT, and ZE and TE are drawn. Which conclusion cannot be proven? Well, even if I'm looking at this picture right here, I know that EA is reflexive, so these two triangles, ZEA and TEA, should be congruent by side angle side because they have ZA and AT to be congruent, and EA is congruent and they have two congruent right angles. So, if I'm thinking about that, all the corresponding pieces should be congruent. So this angle should be congruent to that angle by CPCTC. That side should be congruent to that side, again by CPCTC. And those base angles should be congruent as well. So let's go through these. Number 1 says EA bisects angle ZET. That's this angle at the top right there. Well, that's true because those two parts are congruent by CPCTC, so it cuts it into two halves. Number 2 says that triangle EZT is equilateral. Well, I know that these two sides are congruent, but I don't have any argument to say that ZT is also the same length. So that one actually can't be proven true. Now for EA to be the median of the triangle, that would mean that it cuts the base into two congruent parts, which is exactly what it does. So EA does have to be a median. And number 4 says that angle Z is congruent to angle T, and again by CPCTC those have to be true. For number 4, given those two triangles shown in below with DB congruent to BE, which statement would be needed to prove the triangle ABE is congruent to triangle CBD? Well, the first thing I notice is that they both have angle B in common, and I'm actually going to sketch these two triangles out over here, triangle ABE and triangle CBD. Now, if you're wondering how I put those letters in that order, it was because I knew that A went to C, B goes to B, just because of the orders of the letters here. So they tell me that BE is the same as BD, and I know that angle B is the same on both of them. So that's an angle they have in common, that's a reflexive angle. And if I want to prove these are congruent by side angle side, well, I have a side, I have an angle, I don't need any more angles, so I could rule out 1 and 2. And if I were to have AE and CD be congruent, then they would be congruent by side, side, angle, which doesn't work here. We're looking for side, angle, side. Remember, angle, side, angle doesn't prove two triangles are congruent. So angle, or answer choice 4, actually can't be true because of that reason. So just by process of elimination, we're able to figure out that the answer choice is AD congruent to CE. So if I go back to my original picture, they're saying that that piece is congruent to that piece, which actually means by the addition postulate that BC is going to be congruent to AB. If I go back into my picture, AB congruent to CB. Well, that would give me the side, angle, side that I need there to prove those two triangles are congruent. Remember, the 5 postulates we use to prove the triangles are congruent are either side, 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 proving that all the sides are the same, proving that two sides and the angle between them are congruent, proving that two angles are the same and the side between those are congruent, two angles and a side are congruent, or hypotenuse leg if we have a right triangle. Remember that angle, side, side, or side, side, angle do not prove the two triangles are congruent, so keep that in mind. In order to prove the two lines are parallel, we could either prove that they have congruent alternate interior angles, and remember that's if we have two parallel lines cut by a transversal, either that pair right there, or that pair right there would be two congruent alternate interior angles. We could also show that we have congruent corresponding angles, and that just means that if I've got two parallel lines cut by a transversal, those are two angles that are in the same spot respective to one another. So this one's in the top right, and that's in the top right for that bottom pair. So those are both corresponding angles. If we can prove that those are congruent, we've got that the lines are parallel. And then one that you really won't use too often, but it's still good to know, that the supplementary same side interior angles. And what I mean by that is if I've got two parallel lines, then this angle and that angle are supplementary, and that angle and that angle are supplementary on the inside. So if you could prove that those are supplementary, then you have that the two lines are parallel. But you'll really be sticking with A and B for most of them. Now, in order to prove that corresponding parts of triangles are congruent, remember we always use CPCTC. That stands for corresponding parts of congruent triangles are congruent. If you can't remember what that means, I would write it out every time, but for this video you'll see me use a lot of shorthand. For number 8, if we're trying to prove that triangles are isosceles, you've got two options. You could either prove that there are two congruent legs, that just means the two sides of a triangle are the same, or you can prove that two base angles are congruent, which would mean the two sides are the same. So either of those are enough to prove that a triangle is isosceles. So let's try a proof. Given isosceles triangle ABC with CA congruent to CB, D is the midpoint of AB, prove triangle ACD is congruent to triangle BCD. So the first thing I'm going to do is I'm going to mark up my picture. They're telling me that CA is congruent to CB, that's given, and that D is the midpoint of AB. So if D is the midpoint, that would mean that AD is congruent to DB. So I'm going to start my proof now. I write 2 columns with statement and reason. Now, you would list out your givens here. I'm just going to abbreviate for time. So that's everything they gave us up here. And the first thing I notice is exactly what I marked in my picture, that AD is congruent to DB. My reason being is I know that's what a midpoint does. A midpoint cuts a segment in half. So I'm going to say into two congruent parts. That's the definition of a midpoint. So let's see what I could say after that. I could also make the argument that CD is congruent to CD. And if you're ever stating that two things are the same as each other, remember that's just a reflexive property. Now, if I'm looking at these two triangles, triangle ACD and triangle BCD, I actually have enough information to prove that they're the same because all of the sides are the same. So at this point right here, I have enough to claim that triangle ACD is congruent to triangle BCD. My reason being is that it's a side-side-side proof. Now, this is not the only way you could do it. You could also do this by side-angle-side if you wanted to say that, well, because these two sides are the same, my base angles are the same because it's an isosceles triangle, you could do that too. So for a lot of these, your proof might not match mine, but it still could be a correct proof. Number 10. In the diagram of triangle LAC and triangle DNC below, LA is congruent to DN, CA is congruent to CN, and DAC is perpendicular to LCN. So that means that this is a right angle and this is a right angle. But notice they didn't tell me that they're right angles. So if at some point I need to state that they're right angles, I can't just assume that that's in the given because it's not explicitly in the given. So again, I'm going to start my statement, reason, proof. I would list out my givens, and my reason is just, well, they gave them to me. So let's go through a game plan here. I want to prove that these two triangles in the top and bottom are congruent. I've got two sides already, and I can make an argument that that's a right angle. So what I'm going to say is that for my second choice, angle ACL and angle DCN are right. Now, why am I saying that they're right? That's because perpendicular lines form, that says perpendicular lines, form congruent right angles. So you could use that argument to say that those angles are congruent as well, but that's not how I'm going to use them in this case. I'm going to use them to state that triangle LAC and triangle DNC are right triangles. Now, this might seem a little redundant, but the reason I'm saying that these are right triangles is because if I could state that they're right triangles, I have two hypotenuses that are the same and two legs that are the same, so I can prove these triangles are congruent by hypotenuse leg. So why are they right triangles? Right triangles contain one right angle. And that's enough. So now I could say the triangle LAC is congruent to triangle DNC by hypotenuse leg. And you can only use hypotenuse leg when you have right triangles. That's why that step 3 in there is so important. If I don't say that they're right triangles, it's not legal to use hypotenuse leg. So just be careful there. Now, if I wanted to describe a series of rigid motions that would map triangle LAC, so I'll erase this markup right here, this triangle right here, onto triangle DNC, well, it looks to me like if I just spun it around, maybe counterclockwise by 90 degrees, it would land right on top of it. So this run right here could be a 90-degree counterclockwise rotation. But be careful, because that's not enough. I'm going to say about point C. So when I'm stating a rotation, I need two things. I need the degree in the direction and the point which I am rotating about. So if I rotate it 90 degrees, LC would line up with DC and everything would be okay. Number 11. Given AF is congruent to CD and BC parallel to FE and angle A congruent to angle D, prove triangle ABC congruent to triangle DEF. Alright, this one might be a long one. I've still got my statement reason proof set up. I still always start with my givens. And again, you should write those out This does not count as a given, I'm just shorthanding it for time. And let's see what else we can get going here. So the angles and the sides we can't do anything with, but we got to think about why did they give us those parallel lines as a given? Well, one reason might be is that we can make an argument that since those lines are parallel, angle F and angle C should be congruent because those are alternate interior angles. So what I'm going to say for number 2 is that angle ACB is congruent to angle EFD, because parallel lines create congruent, alternate, interior angles. Again, you should write that out. I'm just abbreviating here. For number 3, though, we need to think about what else we can get going. We've got an angle, we've got another angle, but we don't quite have a side yet. So I'm going to say that FC is congruent to FC by the reflexive property. The reason I'm saying that is because they must have given me AF and CD for a reason. Notice that if I'm looking at the side length AC, it has an FC in it, and if I'm looking at the side length DF, it has FC in it as well. And if I were to, let's say, take AF and add to it FC, that should be the same as if I were to add CD and add to it FC, because those are both the sum of congruent parts. And if I add those up, AF plus FC is just the same side as AC, and CD plus FC is the same side as DF. So that would be enough to state that AC is congruent to DF by an addition property. So you could consider that to be an addition property and a substitution property, but I normally lump those into one step. So let's see here. Now, if I remark up my picture, I've got AC and FD are congruent, so I've got a side, I've got an angle, and I've got another angle. So this looks to me like an angle, side, angle proof. So I'm going to say that triangle ABC is congruent to triangle DEF. Reason being, I have an angle, I've got a side, and I've got another angle. So notice how much I'm marking up the picture here, and when I get stuck, I go back to the givens, and I see what piece they gave me and how I could use it to either get a side or an angle. Number 12, given angle 1 is congruent to angle 2, and AC bisects BD, so that means that DC and CB are the same, prove the triangle ABC and triangle EDC are congruent. So again, I'm going to start here, statement reason. Number 1, the good old givens. And number 2, I'm going to mark what they didn't explicitly give me, but I did say that DC is the same as CB. My reason being that a bisector cuts a segment into two congruent parts. So that gives me one side. And again, when you get stuck, go back to the givens. Why would they give me that angle 1 is the same as angle 2? Well, maybe if I label this angle 3 and angle 4, I could make an argument that angle 2 and angle 4 are supplementary, and angle 1 and angle 3 are supplementary as well, and that supplements of congruent angles are congruent. So let's see what I could do here. I'm going to say that for number 3, angle 1 plus angle 3 equals 180 degrees, and angle 2 plus angle 4 equals 180 degrees. My reason being is that linear pairs are supplementary. So when I say linear pairs, I mean something like this. Two angles that lie on a line that sum up to 180 degrees. Now for number 4, I can make an argument that, well, angle 4 should be the same as angle 3 because supplements of congruent angles are congruent. You don't have to write that. You could actually do a substitution step if you want to. You'll see this written a lot of different ways, and if you see my answer key, I actually did this a different way as well. Now, I'm running out of room here, so I'm going to write it over here. But for number 5, let's see what I've got. I've got an angle. I've got a side. If only I had another angle, right? Well, believe it or not, you could say those two angles are congruent because they're vertical angles. So what I'm going to say here is that be careful how you label these angles. I'm going to label it as A, C, B. You always need 3 letters if you don't have a number for the angle. Is congruent to angle D, C, E. Why is that? That's because vertical angles are congruent. Well, now I have angle, side, angle, so I have enough to say the triangle ABC is congruent to triangle EDC by angle, side, angle again. For number 13, it's always a little bit tougher when the triangles are overlapping. It says that PX is congruent to TY and that RXY is isosceles. So that means it's got 2 congruent parts and it's got 2 congruent angles. I'm actually going to use the angles to help me out here, because if I'm looking at triangle QYP, that angle Y is actually a part of that triangle, and angle X is a part of that triangle. Alright, so I've marked up my picture. Again, I'm going to start my proof. Number 1, always whatever they give you. Make sure you list everything. For number 2, I'm going to state that angle R, or even I'm going to use the big triangle letters. So X, SX, T is congruent to Q, Y, P. So that's those 2 little angles right there. The reason I'm saying that is because an isosceles triangle has 2 congruent base angles. For number 3, I could actually make an argument that XY is reflexive here, because that would get me those bottom sides, PY and XT. So these are the first 3 steps. I'm just going to give myself a little bit more room here because I tend to write a little too big most of the time. So number 4 would be that, and I'm actually going to write it over here. So I could say that PX plus XY is the same as XY plus YT, which would mean that PY is congruent to XT. That's going to be an addition property. So what I did is I took this piece, I summed these 2, then I summed those 2 and said that they were the same because the parts were the same length. Alright, well I've got now a side, an angle. I still need another piece though. But they did give me something I didn't mark in my givens, that angle P is the same as angle T. So I actually do have enough to say angle, side, angle for these 2 triangles. So again, the 2 triangles are congruent. Triangle PQY is congruent to triangle XST by angle, side, angle. And anytime you're asking to prove that parts are the same, that's always going to be proving 2 triangles are congruent, and then just saying that the corresponding parts of congruent triangles are also congruent. So anytime you're asked to prove something that's not 2 triangles are congruent, chances are you'll have to prove that 2 triangles are congruent before you get to that last step. Number 14. Given OP bisects angle AOC, so those two little parts are congruent, and that angle 1 is congruent to angle 2, prove that AO is congruent to CO. So again, this might be one of those issues where I need to prove the top triangle and the bottom triangle are the same, and then just say CPCTC for why AO is congruent to CO. So let's just go through the broad strokes for this one. You could make an argument that angle AOP is congruent to angle POC, or COP, by the definition of a bisector, right? That's because it's getting bisected. This one I'm not going to write out all the way. I'm just going to go through the broad strokes since you've seen the writing out of the reasons a couple times. So that would get me those two reasons. I could make an argument that OP is reflexive, and that would give me a side of both of those triangles. So that would work out to get me an angle and a side. And the question is, how would I get that other angle? Well, they gave me angle 1 and angle 2. I could label this as angle 3 and angle 4. And again, I could make one of those supplementary arguments where angle 1 and angle 3 sum to 180, and angle 2 and angle 4 sum to 180, which must mean that angle 3 is congruent to angle 4, because I already know that angle 1 and angle 2 are the same, because supplements of congruent angles are congruent. Now look at that. I've got an angle, I've got a side, I've got an angle. We're in business. So this would be enough to prove the triangles are congruent, and then just give yourself a CPCTC to say why AO is congruent to OC. In the diagram below, it is known that segment AMB, CM congruent to DM, so I'm going to mark that, CM congruent to DM, CA perpendicular to AB, and DB perpendicular to AB. So I'm just going to mark those two right angles in there. Angle C is congruent to angle D, or they're giving us a lot of information here. Prove that M is the midpoint of AB. Again, like I said before, if we're trying to prove something that isn't related to two triangles being congruent, I'm probably going to have to prove that the triangles are congruent first. So to prove that M is the midpoint, I would have to get that this side length is the same as this side length. Well, if I'm looking at these two triangles right here, it looks to me like I might already have an angle-side proof set up for me. So let's say I'm writing this one out, right? I've got my givens here. As per usual, I can say that angle CAM is congruent to angle DBM. Those are those two right angles. My reason being is that perpendicular lines, again, they create congruent right angles. And then because they gave me all that good stuff in the givens, that's enough to say that triangle CAM is congruent to triangle DBM by angle side. Now, I'm going to say that the segment AM is congruent to segment BM. Of course, if those triangles are congruent, those corresponding parts should be congruent. So corresponding parts of congruent triangles are congruent, which is enough to say that M is the midpoint of AB. Now that I've proved that it's a midpoint, I could just state the reason is that, well, I know the definition of a midpoint. A midpoint cuts a segment into two congruent parts. So I could just defer to the definition of a midpoint because I have proved that M is breaking up AB into two congruent parts because AM is congruent to MB. Number 16. If line M bisects segment AB, so that means that guy is the same as that guy, what is true about each point on the perpendicular bisector compared to the endpoints of line segment AB? So let's say if I take this point right here and connect it to B and connect it to A. Well, the relationship here is that they're actually equidistant from A and from B. So they're the same distance apart from both those. A quick proof could be shown is that, well, if I've got those two right angles right there, this side in the middle is reflexive, and I know that A, we'll call that O, AO to OB is the same. This is actually a quick side angle side proof to prove that these two triangles are congruent and that the corresponding parts are congruent. You can make that argument about any point for both these. Even if you measure with your compass, as long as the picture is drawn to scale, they should be about the same. So from any of the indicated points on line M are connected to both endpoints, what type of triangle is formed? Well, that's going to be an isosceles triangle because those side lengths are the same. Is line M bisected by AB? Well, you have to consider that. What's a line? A line goes infinitely in both directions. You can't bisect something if it doesn't have a length. So the answer here is a hard no, because a line is infinite in length. So you'll never be able to cut it in half because it goes infinitely in both directions. For number 17, in the diagram below, lines P and S are cut by transversals. The angles marked are shown. Explain why P and S must be parallel. Well, if I'm looking here, I realize this is a 180-degree angle. So if I add those two angles up, I get 137, and then if I subtract that 137 from 180 degrees, I end up getting 43 degrees is that angle inside there. Now, if I'm thinking about my rules for parallel lines, I notice that those are congruent alternate interior angles. Remember from the first page is that one way we could prove that lines are parallel is by showing that the alternate interior angles are the same. So my explanation here could just be that there are congruent alternate interior angles, and they are formed by parallel lines. Keep that in mind for the next proof that we're about to do. Number 18. TD, perpendicular to RS, and ME, perpendicular to SR, so that right angle right there, RD, congruent to SE, again, those aren't full side lengths, so maybe I'll have to do an addition property at some point, and RM is congruent to ST. Alright, so I'm just going to get started on this one. They want me to prove the lines are parallel, but again, if they're not asking me to prove something about triangles, and they give me triangles, I'm probably going to have to prove those triangles are congruent. So for number 1, I've got those good old givens. For number 2, I'm going to state that DE is congruent to DE by the reflexive property. The reason I'm doing that again is because I noticed they gave me RD and ES, not full side lengths, but if I have that DE in the middle there, I can make an argument that RD plus DE is the same as ES plus DE. So for number 3, I'm going to state that RD plus DE is the same as ES plus DE, which would mean that the side length RE is congruent to the side length SD, simply by addition. Okay, so that gives me a side. I already have a side. I can't say that angle 1 is the same as angle 4 because I don't know that these lines are parallel. That's what I'm trying to prove here. However, I can state that angle 2 and angle 3 are right angles. So for number 4, I'm going to say that angle 2 and angle 3 are right angles because perpendicular lines form congruent right angles. Now, if I know that they're right angles, I know that they're right triangles. So I can say the triangle REM and triangle DST or SDT are right triangles, because right triangles have one right angle. And if I know that they're right triangles, I can state that they're congruent by hypotenuse leg. So I'm going to say that triangle REM is congruent to triangle SDT by hypotenuse leg. Now, the whole logic behind that is that I've got these hypotenuses here across from the right angle, and I've got these two legs that are congruent. So those triangles must be congruent because they have a hypotenuse and a leg that are congruent, and they're both right triangles. Now, if these lines were parallel, I would know that angle 1 and angle 4 are the same. But if you notice that we've proved the triangles are the same, well, that should not say 5, then you will notice that it is actually already true that angle 4 is congruent to angle 1, because they're corresponding parts of congruent triangles. So I can prove they're the same by CP/CTC. And if I know that the alternate interior angles are congruent, I know that the lines are parallel. So for my last statement, I'm going to state that the two lines are parallel. My reason being is that if your two lines cut by a transversal form congruent alternate interior angles, they are parallel. So if two lines cut by a transversal form congruent alternate interior angles, they are parallel. Now, of course, that's not the only way to say that, but notice the relationship. It's more of an if-then statement. If the alternate interior angles are true, then the lines are parallel. So notice it's in that order, not the lines are parallel, therefore there are alternate interior angles. So just be careful about your wording for those reasons. These parallel line proofs are about as hard as they get, and notice that the triangles stopped right there. So if you can do a parallel line proof, you could do any of these triangle proofs that we've done so far.